Okay, Johannes Kepler didn't stop with one law. He actually stopped after 3, and right now we're on the second of those laws. These are laws of planetary motion. Okay, so if you want to look it up, your textbook, anywhere else, look up Kepler's laws of planetary motion. The first and second laws came in a 1609 book, and they sort of came together. The third one came about a decade or so after that. And here it is in all of its spectacular verbiage right here. Kepler's Second Law. Okay, I'll read it out loud to you, then I'll unpack it a bit. Okay, because it doesn't make any sense when you just read it, but I'll read it anyway to get the words out there and the ideas in your mind. The line between the sun and a planet sweeps out equal areas in equal times. The line between the sun and a planet sweeps out equal areas in equal times. What in the world does that mean? Here we go. So let's pick a planet right here. Let's say that's Earth. Okay. Actually, that's not. Let's say it's Mercury because it's a nice elliptical orbit. Okay. So Mercury. Now, the line between the sun and the planet. Let's start with that phrase. The line between the sun and a planet. Well, there's no line. We draw one. The line between the sun and the planet. So there we go. There's a line. I missed the planet. Look at that. Well, solution to that is move the planet. Okay. So we've got a line between the sun and a planet. Now there's really no line there, but imagine that there was. Imagine you were like Super Spider-Man and you were riding around on Mercury and you could shoot a web out to the sun and make it stick to the sun. Okay. And then as you travel, let's say this happens on day 0, and then 30 days later, Mercury has moved to here. Okay? So it zipped around its orbit, approaching perihelion, and moved that distance. The line between the sun and the planet, okay, we know what that is, sweeps out. Okay, so what happens is that magic line between you and the sun, as you move, that line moves also, right? So it's going to move with you like this. So after 30 days, that line is right here. Sweeps out. Okay. Equal areas and equal times. Okay, what does it mean by sweeping out an area? Well, if you look here, during that time, as the planet has moved, Mercury has moved from there to there over that 30 days, that magic spider web has swept out that area there. Like a little piece of the pie, piece of the elliptical pie. So what we have here is this big area right here. That shaded area. Is that showing up? No, it's not so well. You get the idea though, I hope, that there's this. There we go. So this pen is, all the pens have decided to die at the same time. So we have this shaded area right there. Okay. Okay. So that's the amount of area. We'll call that area A1, because why not, right? So this is area A1. Can you see that? All my pens, friends, are going, they're dying. A1. How's that show? Yeah, that's all right. A1, that's that amount of area. Okay, and then we wait a while, and we do it again. So let's say we wait over here, to over there. We do the same thing. Connect it with a line, and then we wait 30 days. Now we're over here. Okay, so the line is now there. In this 30 days, that same line has swept out this area. My pens are dying. It's very sad. Now we have that area there. Okay, we'll call that area A2. I believe you can see that. Yes, A2. And then we wait a little while longer till we're way out here somewhere. Now Mercury is here, and we're going to wait 30 days. It's going to go, say, to here. Boy, I'm sorry. These pens are really bringing me down, people. In fact, when I try to draw, it erases what I've already done. Okay, so now we have another 30 days. Again, our line between the Mercury and the Sun has again swept out an area oh, good Lord. Has again swept out an area right here. Okay? Is that showing up? I'm worried this is not showing up well. Maybe I'm too worried about it. But I'm going to admit that I have incredibly high standards for my pictures here. We're going to call this area now A3. In all three cases, we've waited 30 days. Okay, so we have three different areas, A1, A2, and A3. Okay. What Kepler's second law tells us is very simple. It tells us that A1 is the same as A2 is the same as A3. All those areas are the same area. They're shaped differently, right? But they have the same, they cover the same total amount of area on the board here and in space out there. Now, this is a little bit of a technical way of saying something that's really quite simple, and here is the kicker. The kicker is this: the closer the planet is to the sun, the faster it moves. Say it after me. The closer a planet is to the sun, the quicker it moves. The closer a planet is to the sun, comma, the quicker it moves. Okay, that is another dying pen telling us what I just asked you to say, which is that the closer a planet is to the sun, the quicker it moves. The faster is probably a better way of putting it. The faster it moves. Okay, which means that when Mercury is down here, whoa, there goes my sun. I try to make my sun brighter and it just goes away. That's what happens with these pens. So here, close to the sun, near perihelion, Mercury is moving very fast. Out here near aphelion, it moves slow. So if we could watch it sort of in a time-lapse kind of deal, it just zip fast and then go slow, and then zip fast and then go slow, and then fast and go slow. So at aphelion out here, planets move their slowest. At perihelion here, planets move their fastest. Right now, the Earth is approaching aphelion. It's approaching its furthest point from the sun. We're probably about 94 million miles, a little bit over 94 million miles from the sun now. In early July, okay, we'll be at aphelion. So right now we're slowing down, reaching our slowest point. And then in early January, we're over here and we're at our fastest point. Of course, the Earth's orbit is far less elliptical than this. The eccentricity is far less. It's more circular, but still, it does make a difference, and the Earth is moving fastest in early January when it's at perihelion, and slowest in early July when it's out here at aphelion. So the clip and save point from this second law of Kepler's is the closer a planet is to the sun, the faster it moves. And the further it is from the sun, the slower it moves. And you can take that to the bank.